Hello there and welcome to the June 2019 paper. We're on paper 2 looking at question 7. So a small factory makes bars of soap. On any day the total cost of the factory Y of making X bars of soap is modelled by the sum of two separate elements, a fixed cost and a cost that is proportional to the number of bars of soap that are made that day. Write down a general equation linking Y and X for this model. So it's just going to be a y equals mx plus c model because m is the proportion of the number of bars of soap that are made that day, the cost of the number of bars of soap that are made that day, and you've got to multiply it by x to get your total cost. So say it costs 20p to make a bar of soap, you've got to take that 20p and multiply it by how many bars of soap you make to work out the total cost for that bit. So m is effectively from part 2 of this explanation here, and C is the fixed cost, which you're always going to incur no matter how many bars of soap you make. For example, employing your employees or employing the warehouse in which you're making your bars of soap, or the factory. So there we are. This is effectively the variable cost, and this here is effectively the fixed costs. Okay, so it's a y equals mx plus c model for the costs. Let's now move on to part B. So the bars of soap are sold for £2 each day. On a day when they sell 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are sold, the factory makes a loss of £80. Using the above information, show that y equals 0.8 for x plus 428. So, if each bar of soap is sold for £2, then on the first day, we'll call it day 1 and day 2 here. So day 1, the revenue, that's how much money they take over the cash register, is going to be £1,600. The cost is going to be, so if it's £2 for each bar of soap, that's how much they're sold for. We make 800 bars of soap, it's going to be 800 M plus C. And we don't know what the variable cost is, and we don't know what the fixed cost is. But we know that the difference between these two values, 1,600 minus 800 M plus C, equals £500. Because this is revenue take away cost. So if I now rearrange this a little bit, and I move stuff around, it's going to be 1,100 equals 800 M plus C. This is effectively a simultaneous equation number 1. Let's move on to simultaneous equation number 2. If the revenue, so if it's 300 bars of soap sold for £2, we are taking in £600. The cost is going to be 300 M plus C, and the difference between the revenue and the cost, 600 minus 300 M plus C, will equal minus £80 because we lose £80 on that day. So therefore, this is my first simultaneous equation. The second simultaneous equation is going to be 680 equals 300 M plus C. So this is my simultaneous equation number 2. So the first thing I'm going to do then is I'm going to do equation 1 take away equation 2. So 1,100 take away 680 is 420 equals 500 M, and the C's will have cancelled out through that subtraction. So if I now divide that by 500, I get 0.84. Divide by 500, I get 0.84 equals M. Okay, so that's M. Now let's plug M back into one of the equations. Let's do it for the second one. 680 equals 300 times 0.84 plus C. So therefore C is going to be equal to 680. I'll do that all on the calculator. 680 minus 300 times 0.84 is 428. So therefore y equals 0.84x plus 300. So no, plus 428. Lovely, there we are, that's the answer to part B. Now on to part C. With reference to this model, interpret the significance of the value of 0.84 in the equation. Well, 0.84 will mean it's 84p to produce 1 bar of soap. It's like the raw materials needed to produce 1 bar of soap, or the variable cost for each bar of soap to be made is 84p. And let's move on to part D now. Assuming that each bar of soap is sold the day it is made, find the least number of bars of soap that must be made on a given day for the factory to make a profit that day. Okay, so what we're looking for then is for the difference between the revenue and the cost to be greater than 0. So the revenue is going to be 2x. That's going to be how much money they're going to bring in. It's 2 times the amount of bars of soap they've sold minus the cost, which is 0.84x plus 428. That must now be greater than 0 because we want to make a profit. So let's work out what x needs to be to make a profit. So if we now expand these brackets, it's going to be 2x minus 0.84x minus 428 greater than 0. Move that 428 onto the other side, and 2x minus 0.84x, 2 minus 0.84 is 1.16. Let's divide by 1.16. 428 divided by 1.16 is... so x is now needs to be greater than 368.9655 ... So therefore, the number of soap made is greater than 369 for a profit. Greater than or equal to. There we are. So that is the that's the point at which we start to make profit. So there we are. That's the answer for question 7. Let's now move on to question 8.